So if I turn the nut, and if I don't allow the nut to move axially, what will happen to the bolt? And where I am giving you a condition that the bolt is constrained to move, constrained to rotate. The bolt cannot rotate. You have a nut, you have a bolt, and you have a nut mounted on the bolt. Okay, you have a nut which is mounted on the bolt. I am turning the nut. I can rotate the nut, but I don't allow the nut to move up and down axially. I don't allow. How do I prevent it? I provide some kind of barrier. I don't allow it to move up and down. I'm turning the nut while the bolt which is there, this bolt cannot be turned. I don't allow the bolt to be turned. This is not possible. But the bolt can move axially. So when I turn the nut, what will happen to the bolt?
Sir, bolt will move up and down.
Bolt will move up and down. So this is the exact mechanism what is taking place over here. This timing guide behaves as a nut, while the barrel thread which is there, the threads on the barrel which are there, they are acting as a bolt, the thread on the bolt which is there. So when you're turning the nut with the help of a VIT rack, the barrel tends to move up or down. The barrel tends to move up or down. And this much play is given. You can see a barrel में एक slot दिया हुआ था. इस slot में one locking screw sits into that. So it allows the barrel to move slightly up or down. When the barrel moves up or down, you know that the relative position of the barrel with respect to the plunger changes. Yes or no?
Yes, yes, sir.
The relative position, ये barrel का जो spill port and suction port, जो spill port का जो position है, this spill port is either going to move up or this spill port is going to move down. So if the spill port moves up, if the barrel moves up, what will happen to the fuel injection timing?
Sir, it will retard.
Delay, sir. Yes, sir. Retard is delay.
Yes, exactly. So it will retard. That means the fuel injection is going to begin later. And if you bring the barrel down, the fuel injection is going to happen earlier. This is exactly what the VIT rack is doing. It is taking the barrel slightly up or slightly down. When the barrel is moved slightly down, it advances the fuel injection timing. When the barrel is slightly pushed up, it retards the fuel injection timing. Can you correlate it with the VIT graph which I discussed?
Yes, sir.
Remember that?
Sir.
Yes, sir.
Yes, sir.
Just a minute. Is that clear all? Let's run the next page. Yeah. This is the one. So here now you can make out that in a MAN and BMW engine up to 40% of the load, no movement of the barrel will take place. Why? Because this is the maneuvering region. You will be, the pilot will be asking the master to keep changing the speed. The master will be altering the course, altering the speed. Sometimes there's a shape, sometimes there's a turning, sometimes he has to slow down, sometimes he has to speed up. So every time doing maneuvering, the load continues to change. When the load continues to change, the VIT, if it is allowed to work in this load range, it will continuously keep moving the barrel up and down. And the barrel and between the barrel and the pump body, there's a seal. There's a dynamic seal. There's a sealing which is provided. So seal can give away. That seal can wear out very soon, and the leakage of the fuel can take place between the barrel and the body. Do you get it? Do you get this point? अगर VIT rack बहुत often move होगा, so that barrel will be very often moving up and down. When the barrel very often moves up and down, the seal between the barrel and the pump body that tends to wear out very soon. Its life gets greatly reduced, and it may start leaking sooner or later, and that will cause the fuel to fall down below heavily. So you can have leakage of fuel between the barrel and the body. Not the barrel and the plunger. अभी नहीं बोल रहा हूँ. अभी मैं बोला barrel and the body of the pump. From there, the leakage can take place. So that is why usually below 40% of the load, the VIT is not put into picture. It does not come into action. Beyond 40% of the load, to increase the peak pressure, what should happen to the VIT? What should happen to the pump barrel to increase the peak pressure?
Downward.
Move down.
Yes, exactly. Very good. So the barrel must move downwards. So barrel has started moving downwards, and advancing of the fuel injection timing is taking place from here to here. So advanced barrel is continuously moved slightly downwards, lowered, and you are getting an earlier injection right up to the 85% of the load. At 85% of the load, the Pmax has been achieved already, and thereafter the Pmax, the engine maker wants to keep the Pmax same, constant. So what happens to the fuel injection timing and the barrel position now after 85% load up to 100% load?
Pressure remain constant.
Sorry?
Sir, because retardation means keeping the pressure constant, retardation is occurring. So either it will be move up a little bit or remain constant.
I think.
Not remain constant. It has to be moved up. If it is not moved up, okay, if it remains at that position, it may go up like this. You can see this graph. ये example है. अगर आप VIT को action में नहीं लाएंगे तो graph will move like this. With the change in load, the peak pressure will increase. So इसलिए it will go like this. It will follow the green line over here. I don't want at any point of time the maximum Pmax to be exceeded in my engine. I have to maintain that. That's the limit of Pmax. That's the limit of pressure. So I can't afford to do that. So I need to start retarding the fuel injection timing. After 85% of the load, the fuel injection timing must be retarded. The barrel will be now slowly pushed upward. Is that clear?
Yes, sir.
Yes,
And why 85% target has been kept? Why not something else? Why not 80%? Why not 90%? 85% क्यों रखा गया? Any idea about that?
NCR value.
Yes, exactly. Because it's the nominal continuous rating. The nominal continuous rating is generally 85% of MCR or nominal continuous output. Okay, normal continuous rating also sometimes we call it as. Usually the engine is run at that, around that. So that is why you want that the engine efficiency must be maximum at the nominal continuous rating point. Is that clear to everybody?
yes,
Yes,
sir.
sir.
Yes, sir.
So I hope that it clears all your doubts on VIT. Do you have still any remaining? Please feel free to ask. Achha, who is causing? Achha, VIT rack is causing that. Good question. Let me come to that. Let me come to the mechanism for MA and BMW engine, how it is happening. ये mechanism है. The mechanism is over here. Okay, this is only for your understanding. Okay, block diagram of the same can be drawn. You don't need to show the internals. If you're showing it, if you are explaining it, just block diagram will suffice. Linkages and block diagram will suffice. यहाँ पे कुछ linkages दिखाए हुए. Some linkages are shown. I'll try to explain with the help of this diagram. You see that VIT coming into action is linked with the load, right? So when the load goes beyond 40% and up to 85%, some action will take place. Beyond 85%, some other action will take place. So there has to be a feedback from the governor. There has to be a feedback from the engine load coming over here. So that is why you can see governor output is fed back over here. Then you have a pressure reducing valve which is provided over here. Pressure regulating valve, I'll call it as, is a VIT pressure regulating valve. It's a VIT pressure regulating valve which is there. This pressure regulating valve, you know, pressure regulating valves, how do they work? The pressure regulating valve will be continuously adjusting the pressure. For example, I'll give you an example. Let's say that you have a pressure regulating valve mounted here in the system. Output may you always want 7 bar pressure. Input can vary 15 bar to 30 bar. But output I always want as 7 bar. So this pressure regulating valve has got a system feedback mechanism where it can take a feedback of the output pressure. Okay, and it will try to open or close the valve in such a way that always at output 7 bar pressure will be maintained. Even if it goes below, say 30 bar, 25 bar, 20 bar, 15 bar, and if the pressure regulating valve is designed to operate between 10 to 30 bar, 10 bar inlet also will be able to give you 7 bar outlet. That's how the pressure regulating valve actually works. Is that clear?
Yes, sir.
It's different than pressure reducing valve. Reducing valve क्या करता है? By set amount it will reduce. So 30 का वो अगर 7 लाएगा तो 25 का वो 6 ले आएगा. 20 bar का maybe it may reduce it to 5.5. Okay, 15 bar का it may reduce it to 5 bar. Something like that. Okay, or maybe 4 bar. Something like that. But regulating valve will always maintain the pressure at the output. So you have some pressure regulating valve. You have a 5.5 bar air inlet which is taking place. But the output of the air, that will vary. Output of the air will vary according to the load. Agar load ज़्यादा है, तो governor output will shift this. You will have more or less. So when this shifts, this linkage, this point shifts like this. When this shifts like this, is going to pull this point. Oh no, not pull this point. When this moves up like this shaft is going to turn like this, and this is going to take it this way. So when this moves this way, it's going to block this passage more. The air inlet which was coming, okay, now lesser air will be able to go out. So when lesser air is able to go out, the VIT servo is nothing but it is a pneumatic cylinder. This pneumatic cylinder ko, when lesser air is going from on other side, you may have a spring. So when the air pressure reduces, it will pull the VIT rack out. In other words, it is advancing the fuel injection timing. So when the rack is being pulled out, it's bringing the barrel down and it is advancing the fuel injection timing. When the governor load, keeps on increasing, there'll come a time that this mechanism is made in such a way. There'll come a time that when the load reaches 85%, beyond 85%, the moment it crosses, the air pressure will start to increase. So that is not very clear from this drawing. But when the linkages move to such an extent, you will have internal arrangement in such a way that you will have the air pressure which is coming in, that will increase, the output will increase, and you'll have the VIT servo being pushed in. When it gets pushed in, you'll have the retardation of the fuel injection timing taking place. You'll have the barrel being moved up. Is that clear?
Yes, sir.
So governor will come into picture, and the correct setting, correct calibration of this valve and correct calibration of this VIT servo. These two are very important factors. If they are not set correctly, the VIT cannot function correctly.
Sir, can you explain once more when you said when lesser air goes out in above part of VIT servo and VIT rack timing, what was happening over there, sir?
See, ये VIT servo क्या है? Basically, ये एक pneumatic piston है. ठीक है, एक सिलेंडर है, इसके अंदर एक पिस्टन है. This piston may be loaded by a spring, or it may have air pressure from both the sides. Okay, and this is connected to let us say this is connected to the VIT rack. So air pressure, I am talking about this air pressure. If I increase this air pressure, what will happen to this piston? If I increase the air pressure, the piston will be
Outward motion.
Rest.
right word, right?
Yeah,
It will
right,
have a rightward motion. That means it will push the VIT rack in. Assuming that pushing in of the VIT rack causes the, retardation, and pulling out is causing the advancement. So I can put it over here, retard, advance. So initially what you will find as the load is increasing, initially you will find that as the load is increasing, this passage will be blocked. So you have the air pressure. This linkage is designed in such a way that it is going to reduce the air pressure going to the VIT servo. When the pressure gets reduced, the servo moves in the leftward direction, causing the rack to be pulled out and causing the advancement of the fuel injection timing to occur. But the internal construction of this regulating valve is such that when the load reaches greater than 85%, it will start to retard the fuel injection. Is that clear? उस समय क्या होगा?
Yes, sir.
जो air pressure which is coming 5.5 bar, that air pressure, instead of getting reduced, it will start getting increased, and the VIT servo will get more air pressure, causing the servo cylinder to move rightward, causing the fuel, the VIT rack to be pushed in, which means that the barrel is moving upward, which means that you have a delayed fuel injection taking place. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir. Excuse me, sir.
Yes.
Sir, means still 85% of that load, sir, air input will be near about 5.5 bar. And if it exceeds that 85% of load, then air pressure will increase now from 5.5 bar to further.
नहीं, ये जो air pressure यहाँ दिखाया हुआ है, this air pressure is the inlet air pressure. That means this is the one which is supplied to this regulating valve from the control air system. इसका जो आउटलेट जा रहा है, ये रेगुलेट किया जा रहा है इस वाल्व से. So it can go to a maximum of say 5.5 and minimum of 0, let us say. 0 तो नहीं होगा, कुछ ना कुछ प्रेशर हमेशा आउटपुट होगा. So this is the one going to the VIT servo which is getting regulated. Is that clear to all?
Yes. Yes.
Yes, sir.
Okay, now I'll tell you, I'll come back to the Sulzer.
Sir, one doubt.
Yeah,
Sir, barrel is moving up and down with the wings of rack.
hmm.
Then, sir, those two valves like spill valve and suction valve will also move.
अरे स्पिल वॉल और सक्शन वॉल तो सल्जर टाइप ऑफ पंप में है ना. यहाँ पे कहाँ है? MANBNW टाइप ऑफ पंप में स्पिल वॉल और सक्शन वॉल कहाँ है?
Sir, port.
तो बैरल में ही तो पोर्ट है. The port is drilled into the barrel only. When the
Yes, sir.
barrel moves up and down, the ports are moving up and down.
Then, sir, there should be a fixed pipe, na? So that fuel.
Pipe is connected not to the barrel, pipe is connected to the pump body, which is fixed. Pump body is fixed, the pipe is fixed.
Got it, sir.
Okay. Any more questions?
No, sir.
Okay. So now you have got the understanding of MANBNW type of fuel pump, also understood that how VIT will be functional in this type of pump. Now, going back to the Sulzer type of pump, now since you know that what is VIT, how it is working, how it is beneficial, and how it works for a MANBNW type of pump, you should also know that how VIT will be functional for this Sulzer type of pump. So can somebody explain to me? I think we already discussed. Roll number 8 can enlighten us. Can you hear me?
Yes, sir.
So can you enlighten the class as to how VIT is taking place in this pump?
Sir, if VIT is less than 40% of load, then it is not in action till then. After 40% of load to increase the peak pressure, the barrel will go downwards and timing of fuel injection is going to advance.
Stop. What do you see on my screen?
So, Subzerwal.
इसके बारे में बात करो. Talk about this.
We have to rotate the eccentric cams in this.
Which cam? Which eccentric cam? Which one?
Sir, the right eccentric cam. Suction side.
Okay, suction side. क्या होगा उससे? Suppose I turn this eccentric cam anti-clockwise. Can you explain what all things will happen because of anti-clockwise turning of this eccentric cam over here? I'll just annotate over there. If I turn it anti-clockwise.
Sir, it will retard if we will turn anti-clockwise.
Why will it retard the fuel injection?
Sir, the plunger will go up. And
Plunger कहाँ है?
sir,
How
the
the
fulcrum goes up and it will be closing late.
fulcrum goes up, causing the push rod to be pushed up, causing the suction valve to remain open for a longer duration, right?
Yes, sir.
Okay, very good. So, in effect, now you know, you can mute yourself. Yeah. So, in effect, you know that the VIT control mechanism, whichever is there, should be able to control this turning of this VIT regulating shaft. इसीलिए यहाँ पे आपका VIT rack नहीं है, you have a VIT regulating shaft which is there, right? And mounted on which you have a eccentric cam, and when you turn that, you will be causing this push rod to move up or down. If you are moving the eccentric cam down, you're causing the eccentric cam to move like this. What will happen to the fuel injection timing? इसको clockwise घुमाया, so your pivot point is going to go down, push rod is going to go down, and this is going to close early.
Early, sir.
Right?
Advanced.
Which means you have an advancement of fuel injection timing. I hope you understood whatever I wanted to convey.
Yes,
But
sir.
please understand that this control is a dynamic process. While the engine is running, there will be a control system which, according to the engine load, will be altering the position of this shaft, turning it clockwise or anti-clockwise, right? And trying to achieve the VIT and trying to increase the Pmax and hence the mean effective pressure and hence improve the specific fuel oil consumption. Is that clear?
Yes, sir.
Okay. Now, there is another term known as FQS. Anybody has heard of this term?
No, sir.
Please note it down. Can anybody tell me about what is meant by quality of fuel oil? Can somebody tell me about the same?
So maybe
The
it depends on
viscosity of fuel.
viscosity, calorific value.
No viscosity, no calorific value. What is meant by quality of fuel oil? Which parameter do we consider when we talk about the quality of fuel oil?
Sir, maybe the
So the trace contaminant.
Injection delay. Sorry.
Yes.
Composition, sir, to prevent SOx and NOx.
You have studied about the fuel properties in the last semester. I'm referring to one of the properties of the fuel about which you already know, you have already studied about that property. Which property, which parameter of the fuel, which property of the fuel, which parameter which will be tested in the laboratory is a measure of fuel oil quality, which is considered
Last point, ignition point,
no,
octane cetane rating.
Sir, CT.
no. I'm talking about heavy
Sir,
fuel
how
oil.
much time
When
will
we
take
talk
to
about
turn
the
down?
distillate
Sir,
fuels, yes. Huh?
4 point flash
No,
point.
no.
ECAI, sir.
Ignition
What
lag.
is that? Yes.
Sir, ignition lag.
हाँ क्या बोला क्या कौन सा क्या term बोला? What term did you say?
Sir, CC.
Come again.
Sir,
हाँ
ignition lag.
CCAI ये CCAI क्या चीज है भाई?
सर वो कोई एरोमेटिक इंडेक्स फ्यूल का कार्बन कम
Canada Columbia
No,
aromaticity
sir, carbon
index,
content aromatic index.
carbon content aromaticity index, crankcase aromaticity index. Anything else?
Calculated carbon aromatic.
Calculated carbon aromacity index, aroma. Okay, calculated carbon index. क्या होता है ये कोई बताएगा? What is this?
Sir, CCAI is a calculation which is based on the density and viscosity of the given fuel.
Okay, density and viscosity of the fuel.
Yes.
Okay, and what does it signify? ये CCI value जो है जब when the lab report you get and you get some CCI value, do you know that what maximum CCI value is permitted to be burnt in your marine diesel engines? What
Sir,
maximum CCI value?
870, sir.
Okay, very good. 870 CCI value maximum permitted, which you can burn. Now, if you have two fuels with you, right? You have two fuels with you. One with a CCI value of 830, another with a CCI value of 850. Right? Earlier, you were burning fuel with CCI value of 830. Now you have received fuel which is having a CCI value at 850. What action will you take and why? Before you start burning 850 CCI value fuel.
Sir, since the delay will be more in 850, we have to adjust the fuel injector accordingly.
Fuel injector?
Not the fuel, like the fuel injection timing we will have.
Very good. So you'll have to adjust the fuel injection timing. Where do I adjust? Which direction do I adjust the fuel injection timing?
Advance कर लेंगे sir.
Yes, advancement. Because my injection and ignition gap, जो कि ignition delay बोलते हैं, that has increased. I want the characteristics of the engine, the power generated to remain same. If I don't take action of advancing the fuel injection timing, say by half a degree or 1 degree or whatever is needed, then my ignition will not start at the same point at which I desire it to start. And when my ignition does not start at the same point where I desire it to start, my combustion characteristics will change. So that is why the fuel injection is advanced. Okay, I think I'll draw it again. So earlier the injection was taking place here, combustion was starting over here, point 1, point 2. But now, because there is a greater delay, I start my fuel injection here, 1 dash. and the delay is now more. You know that. And I still want my combustion to start at 0.2 so that the characteristics, they remain same. But remember, there is a drawback. If there is a too much of delay, there is a too much of delay, then too much of fuel will be accumulated by the time the combustion starts, and that will cause a very sharp rise in pressure, which is often known as which is often known as
fast burning.
अरे which is often known as, पढ़ा हुआ है तुम लोगों ने, you have studied about that.
Sir,
ये
can you please repeat?
very sharp. हाँ, शूटअप क्या बोलते हैं उसको, टर्म बताओ मुझे. शूटअप प्रेशर, अरे टर्म बताओ मुझे. शूटअप प्रेशर नहीं है.
Sir, can you please repeat? My net got stuck in between.
Okay, I'll repeat. See, if the fuel quality is bad, instead of 1, you will start injecting the fuel at 1 dash, right? If the fuel quality is further bad, maybe you may start injecting the fuel at 1 double dash. But if the fuel quality is so bad, the CCAI value is greater than 870, it's greater than 870, then the ignition delay is simply too much. And if you start your fuel injection too early, over here, too early, then there will be too much of lag. And you will have very high quantity of fuel getting accumulated before the combustion starts. And when the combustion starts, there will be a sudden explosion and you will have a very high peak generated, very high peak generated. What is this phenomena known as?
Knocking.
Now,
Knocking.
yes, very good. Who is that? Knocking, who said that? Who said that? Knocking?
Sir, 2-3 people simultaneously remembered that, I think.
Amit Singh, sir. Amit Singh.
Okay. Roll number 10.
Yes, sir.
Yeah. So very good. Amit Singh किधर है? Roll number 10 तो
Sir,
Abhishek है. Who is that?
He is 26, sir. Roll number 26.
So he said that? Okay. Anyway. अच्छा ठीक है. ठीक है. तो ये इसको knocking बोलते हैं. और knocking is a special condition. ऐसा नहीं कि हमेशा जब हम एडवांस करेंगे तो knocking होगा. Knocking is special condition when the poor quality, too much poor quality of fuel is there, then knocking it can cause. Okay. Now coming to the point. Why I took you again? I digressed you deliberately from the topic. It's a deliberate digression from the topic because until I go into this, there's no point in telling you what is FQS. Now coming to FQS. Now FQS क्या चीज है? एक knob or adjustment is given on Sulzer engines. FQS is only given on Wärtsilä Sulzer engines. Sulzer 2-stroke crosset type of marine diesel engines. It's only given on these engines. And there they give a setting. वहाँ पे एक pointer दे रखा होता normally with a knob or some kind of lever adjustment. और यहाँ पे वो 0 degree लिखा होगा. यहाँ पे -0.5 लिखा होगा. -0.5, -1, -1.5, -1.5 और -2 ऐसे करके लिखा होगा. यहाँ पे प्लस साइड भी होगा. +0.5, +1, +1.5 एंड +2. इतना डिग्री नॉर्मली चेंज कर सकते हैं आप फ्यूल टाइमिंग में. मैनुअली आप एडजस्ट कर सकते हैं. व्हेन द दैट कैन बी डन मैनुअली एंड दैट इज अ परमानेंट चेंज टिल द टाइम यू अगेन रीएडजस्ट इट. So by changing that knob, FQS knob or FQS lever, which is given on the engine, normally this is given at the control stand, local engine control, local control stand or emergency control stand of the engine. वहाँ पे ये FQS lever दे रखा होता है. So you can adjust the fuel injection timing. You can retard it or advance it based on the CCI value of the fuel which you have received, which you are going to burn. Did you get it?
Yes, sir.
Yes, sir.
अभी ये करता क्या है? What is it?